Okay, thank you. Yeah, I'm going to talk today a little bit about making beats with a library called BAP that I made and the WebAudio API. Won't dive into the technical details too much in the actual talk, but feel free to ask about that after. First of all, who am I? I'm working at a company called Six Wunderkinder, and I build an app called Wunderlist. You add lists and tasks, nothing fancy, but I do JavaScript all day. I'm also into making music. Although I don't have no musical talent, I can't play any instruments. I do like machines, and drum machines in particular. I'm also a bit interested in the WebAudio API now, obviously. Okay, so about a decade ago I met this guy for the first time. This is an MPC 60, and by the time he was almost 20 years old. And I instantly fell in love. But not for the same reason that most people who meet this guy, which is the 16 pads. But for me, it was this view. Amazing, right? So the edit or the event edit view meant that I had a way to read notes, to reason about music, to actually hear from this screen. You can move, add, build your whole beat without actually having any sense of rhythm. You just have to be able to listen. And now, jump to present day, I find myself falling in love with making music again, or rather hacking the process of making music. As a JavaScript developer, I have the capability now of actually building my own instruments, which is kind of cool. Which is what I did then, and what I'm about to show you today. So I made something called BAP, which is a small library for making beats that's inspired by the MPC workflow. With MPC workflow I mean loading samples, chopping them up, and sequencing them into some kind of beat. Everything is built to be modular and reusable, meaning that you take a kit, a loop, even a sound, put it in an NPM module, send it to someone else, or collaborate on it. And since everything is in code, it also means that you can use all the existing developer tools and collaboration tools like GitHub or whatnot. Okay, so it's based on 96 ticks per beat, which will feel familiar with anyone who's done MIDI. It's the same time signature, position signature as the MPC 60. So this basically means that we're looking at the range of one full bar from the first. Yeah, it's notated as bar.beat.tick. And we have a few different things different structs in here. We have a kit that's like an instrument. So you would have an infinite amount of slots, and into these slots you will input layers that are made of samples or oscillators. And then to trigger them, we would create patterns that are playable collections of channels which contains notes. And these two connected together would make some music, hopefully. And this is how we would define a note. So you could have lots of parameters when you want to schedule music or schedule events in a beat, but the 6 most important ones here would be the position, the key, which is a combination of a letter that we would give, an ID that we would give our kit, and the slot number. You could have a duration, which is the length of playback defined as ticks. And then we have volume, pitch, pan, and then we can go on with other things. Okay, so let's look at some, you already heard this demo, but let's look at how it's made. So we would create, require the BAP library and create a kit. We call it beep. And in this case, we create an oscillator template. So this is an oscillator. If you're familiar with the WebAudio API, it's a little thing that makes a beepy sound, makes a sound wave. And we give it some parameters. In this case, attack and release. It's pretty self-explanatory. The length is defined in seconds, as most things in the WebAudio API. And on the next slide here, we would clone this template oscillator into 2 slots. So into the BAP kit, the first slot, I add a layer, which is the basic oscillator, but with the frequency 330. And in the second example, I do the same thing, just showing that at every step, I have an object that I can cache and put in a module, or I could have a factory function or something to do something interesting with it. And then we need to schedule this. So we would create a pattern. We create something with 2 bars and set the tempo to 140 BPM. And to the first channel of this pattern, we add 2 notes, and they look kind of funny, right? Asterisk and percentage sign. So these are actually note expressions, meaning that they will be expanded to more notes. And I will touch on that in a second. The last line is the more important one, where we connect our kit that we just created with IDA in this pattern. So meaning that the key here, A1, will play the BAP kit slot 1, and yeah, so on. So just short on the position expressions. You have wildcards, which would match anything. You have the modular operator, which works as modulo in JavaScript. In this case, it's with an offset of 2, so we start counting from 2. So basically we want to make a metronome that has a first tick and then 3 more. Okay, so, and then we have even and odd, which are pretty self-explanatory. And yeah, this is what it sounds like with those few lines of code. Pretty cool, I think. I've listened to this many hours. Okay, so down to the nitty-gritty. We're gonna make a beat. We're gonna use a few samples, a few drum samples, some string pads, and a bass. And so we created a kit again to illustrate 3 different ways of doing the same thing. It's slightly different here. The first one is a shorthand way of just passing a URL into a layer, and I create a sample assigned to this layer. The second is creating a sample object and passing that into a layer. And in the third one, we're assigning a sample to a numbered layer, meaning that we could override an existing layer. So, yeah. And we set the volume here of this sample so that we wouldn't have to do that in each note.
So what does the first parameter, the 1, will it override?
It's like an ID. It's a 1-based index. So it's channel 1.
So like this layer has like several, you can have infinite channels in one layer. Samples playing at the same time.
Yes, on each slot you could have infinite layers. So think of a slot as a string on a guitar, and that string could play, yeah, more than 1 guitar sound.
So what does the third thing do? It says slot 3 and then layer 1?
Yeah, so that's putting it on the first layer. The other ones are also putting it on the first layer. I'm just showing that you would be able to put it on a number, like a specific layer, if I wanted to override it.
So the kit has infinite slots, and
Yeah.
each slot has infinite layers.
Genau.
Alright.
Okay, so this is slightly more involved. I won't go into the details of actually why I'm putting each note in a certain spot, but we create a pattern here. We have a slightly more hip-hop tempo, 90 BPM, and to the first channel we're going to add a bunch of notes. If you're interested in why I'm putting notes in each place, I've written about it in a post called Lazy Kicks and Eager Snares on the website I showed in the beginning. What you can look at here is that changing the volume basically on a few of the kicks. So I'm going to connect the drum kit pattern to the IDA, and then the first slot was the kick. So A1 would be the kick. A2 would be the snare. So I'm also going to add some hi-hats, and again I'm using now the position expressions, so I don't have to write each note on its own because they're all the same, most of them anyway. And then at the end I connect the drum kit to the IDA. If I'm making no sense, someone raise a hand. No. Okay. And let's play some drums. So, pretty bare bones so far, but yeah, we go on. We want to add some other samples. I digged up some plongs, we call them. And in this case, we're defining a duration, which would be the max duration that they play, and that's defined now as in ticks. So it would be variable with the BPM, the tempo of whatever beat we make. I schedule them again. I'm just adding notes, and then assign the kit to ID B. So B1 becomes plong kit slot 1, and it would then play each layer on that slot. So we get some plongs. Okay, so we're going to add some more samples, strings. This is basically the same. We're adding a few more samples, defining the duration. Here's a slightly more interesting thing, that the 4 first notes here are half beats of the same key, playing the same sound, but we will change the volume to create a manual delay effect. And at the end, you see we're changing the duration, and this will override the duration that I set in my kit. So it will get merged up the chain from the note to the layer to from the note to the channel to the layer to the slot to the kit. Yeah. Okay. So we're just going to add some bass. In this case, we set the attack and release to we don't want to have any cracks and pops, and schedule it with some pitching up and down to hopefully make it sound not completely out of tune. And here we're using the duration to really create like a rhythm of it. That's true. That's a little bit hard to hear. Okay, I have one more short demo, which is how you would, well, I said in the beginning that the MPC workflow is about taking a sample and slicing it, of using several different parts. So we're going to do that right here in 2 different ways. The first way is if I know where the slices start and end. So I'm just going to load a sample here again, a bass sample or a template sample, and then to the first slot I'm going to assign a clone of that sample, but with an offset and a length, meaning that I will start playing after 72 milliseconds and then keep on playing for 719 milliseconds. And I do that with another sample, and then we have number 3 and 4, and that should, yeah, and then we need to schedule these. Basically just adding the notes to full beat notes to begin. And then at the end you see I'm using some math to calculate that it would actually end at the end of the bar. Because this is not a text file but a JavaScript file, I won't be able to do that. And then assign this all to the kit to IDA and start playing. Wait for it. It's coming soon. It's hard to hear. This is only the left channel. That's fine. Okay. So it's playing the samples, the different pieces, different slices of one buffer. It's actually creating new buffers from it. And final little demo is we're going to make an auto slice kit. So imagine you have a breakbeat or something that's already an even measure of beats. In this case I have something that is 16 beats, and to create a sample, I pitch it down slightly because it should match the thing that we just made, and I slice it in 16 pieces, and I get a kit. So a kit with 16 slots, all the same sample, but with different offset and length. Well, the same length, but different offset, so it's starting at different points. And I'm also just adding a kick and a snare to a few of the slots here as a second layer to give some oomph to the break. And I've scheduled that. It's pretty straightforward, even beats, except at the end, you add a small fill there. And yeah, that would sound, if it loads. So, that was it. I have this website, I've just put it up with the links to the documentation, and if anyone wants to have a look. It's still pretty early with me developing this. If anyone wants to get involved and help out, that would be cool, putting an MPC in the hands of a console. If you want to know what's happening or when there's updates and stuff like that, follow me on Twitter. And yeah, that's it.
So I could see in your programming that you were using the 96 ticks you had by not just so you were really using the kind of fine granularity of the 96 ticks you had per bar.
Yeah.
Yeah, typically you could just like divide it in 4 or something, and the beat would just sound like kind of like very stuck and
very straightforward.
Yeah, exactly. Yeah. So you were kind of putting some groove in there, right? Like that's the point of the 96 ticks, right? But can you kind of apply grooves like typically what you do in like audio workstations, like say like, I want a 50% swing groove, like.
Well, yeah. Of course you could do that. I mean, there's you would in this case how I'm programming the drums. The kicks are mainly lazy and the snares are eager. You would have some kind of knob to make the snares more lazy or more eager and the kicks more lazy. It's definitely possible, but it would be in this case be done within the 96 ticks, which is in my experience enough resolution. A lot of drum machines after that has they're working at 960 ticks, which is you don't need that. It's like,
but on the MPC, you have to do that as well? On the MPC, can you just set a shuffle or however it's called? Like
there's a swing setting.
Right.
Maybe I add that here also, but it would be slightly more involved. The MPC swing setting is basically just taking the half beats, moving them a little bit forward, and then the beats that go on 2 and 4, moving them. They're all moving a little bit forward. So it's basically making half beats lazy. So you don't get this Dilla-ish early snare feeling.
But it's still completely like the fact it becomes boom bap is more like depends on how you choose these values, right? In a way.
Yeah, it could. I mean, boom bap is a kick and a snare. So
okay. I was expecting you would give more like the actual numbers, that would generate more like the boom bap pattern in a way.
Yeah, I mean those numbers that I'm using there, they will produce let's say a rhythm that is boom bappy. Yeah, definitely.
Yeah. Okay. Sorry.
Yeah. Anyone else? Okay. Cool. Thanks.